Now we are going to deal with elementary operations of a matrix. Okay, so we are going to deal with the elementary operations related to the rows. In the case of rows, two rows can be interchanged. If I am taking R1 and R3, R1 can be changed to R3 and R3 can be changed to R1. For example, if I am taking a matrix 1, 2, 3, 4, 5, 6, 7, 8 and 9, which is R1. R1 is 1, 2, 3 and R3 is 7, 8, 9. In the next step, I can interchange both the rows R1 interchanges to R3. So what will be the corresponding next matrix will be, first row will be 7, 8, 9, which is the third row of the above matrix. Second row remains the same 4, 5, 6 and first row becomes the third row here 1, 2, 3. So this operation, this transformation is the first one in the case of row. So this transformation is possible. We can interchange any two rows. Okay, R1 and R2 can be interchanged, or R2 and R3 can be interchanged, or R1 and R3 can be interchanged. Rows can be interchanged. Again, the second operation what we can do is we can multiply one row with a constant. If I am taking R2, I can multiply the row, each and every element of second row with a constant. Again, for example, if I am taking a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, I can multiply 5R2. Second row changes to 5R2. That means the elements of the second row can be multiplied by 5. So what will be the corresponding matrix? First row remains the same 1, 2, 3. For the second row, what we have to do is multiply each and every element with the 5. So first one is 5 into 4, 20, 5 into 5, 25 and 6 into 5, 30. And the third row remains the same. So this operation is also, this elementary operation is also possible. So the first one was interchange of two rows. The second one was we can multiply one row with a constant. And the third one is we can multiply one row with a constant and add it together with another row. So here I multiplied the third row with a constant k and I added it with the R1 and the change is for R1. R1, this read as R1 changes to R1 plus KR3. What I want to do is I want to multiply the element, each and every element of the third row with the k and I have to add those elements, corresponding elements with the R1. So here again we will take an example. Let it be 1, 2, 1, 3, 4, 5. 2, 4, 6. Okay, so I am multiplying the third row with the 3. So 3 are 3. And I am going to add first row with the third row. And I am interchanging R1. So I want to do the elementary operation for the first row R1 and R1 gets changed to R1 plus 3R3. R1 plus 3R3 means I want to multiply the every element in the third row with the 3 and then add the corresponding element to the first row. So what will be the matrix then? Second row has no change, 3, 4, 5. Which row has the change? R1. So third row also remains the same, 2, 4, 6. What we have to do with R1? We have to multiply the third row with the 3 and add it to R1. So 3 into 2 gives you 6. 6 plus 1 gives you 7. Clear? Third row we have to multiply with the 3. So 3 into 2 gives you 6 plus R1, isn't it? So 6 plus 1 gives you 7. Second element, what will be the second element? So this is the second one. What we have to do is first multiply it with the 3. So 4 into 3 gives you 12. 12 plus the corresponding element 2 gives you 14. Okay, what about the third element? We have to multiply 6 with the 3. 3 are 3. So 6 into 3, 18 plus R1. So 18 plus 1, 19. So the matrix after elementary transformation will be like this. Okay, so three elementary operations related to row is interchange of rows. Two rows can be interchanged. Again, we can multiply a row with a constant. Again, we can multiply a row with a constant and add it with another row. Okay, so these are the three operations for the rows, and again the same operations can be done with the columns also. So there are 6 elementary operations or transformations.